Okay, good morning. Well, at least for me. Welcome to our sixth video of Unit 5, Molar Volume of a Gas. So, there's not much to this video. There's not much new material, except for one main thing. At the same temperature and pressure, 1 mole of a gas will have the same volume as 1 mole of any other gas. Let me say that again. If we have the same temperature and pressure, basically the same amount of any two gases will cover the same volume. Now, what we find is that at STP, which again refers to standard temperature and pressure, which refers to 273 Kelvin and 1 atm, the volume of 1 mole of any gas is 22.4 liters. That says that any gas at STP will take up 22.4 liters. Okay, kind of a random number, I know. That is what you really need to get. Okay? So, the rest of this video is basically us practicing and using that material. And yes, welcome back to moles and grams. So, to begin with, how many grams of sulfur, technically are there, sorry, in 2.00 liters of sulfur when it's at STP? You got about 3 minutes. Try and figure this out. All right, welcome back. So we know that we're at STP. And at STP, 1 mole of anything is equal to 22.4 liters. Okay? Thing is, we have 2 liters. So, 2 liters times 1 mole over 22.4 liters gets us now moles of sulfur. However, we want grams of sulfur. Molar mass of sulfur is 32.07. Plug that in your calculator and you get 2.86 grams of sulfur. Now keep in mind, that says that in 2 liters, like a full 2-liter bottle of sulfur gas is going to weigh about 3 grams. That's about the weight of 3 paper clips. So, gases are stinking light. But there you go. 1 mole is that at STP. Convert liters to moles, moles to grams. You're done. All right, here's another example. At 40 degrees Celsius, a 691 milliliter sample of ethyl ether has a mass of 101.65 grams. What is the molar mass of that? Okay, so this is obviously a little bit more complicated, but it's only because there's basically 2 steps. Our video says, our notes say, that at STP, 1 mole is equal to 22.4 liters. Here's the issue though. STP is when we have 273 Kelvin and 1 atm. Okay, we're not at 273 Kelvin, and there's no mention of pressure. However, we learned what are called gas laws. We're able to say, hey, if we have this volume at this temperature, what would it be if we change our temperature? So, step 1 is we're going to get what is our volume at 273 Kelvin. Okay, so we've got our current temperature and our current volume. So we're saying, what if we change our temperature to that? What's our new volume? And then secondly, we're going to get our moles. And then step 3, take the grams they gave us and divide it by the moles that we just got, which is basically going to be 1.65 over our answer to number 2. I know it looks hard. There's not a lot of work though. Okay? So step 1, new volume. Step 2, get that volume to moles. Step 3, divide the grams they gave us by our moles. All right, come back in a bit. Okay, welcome back. So, step 1 is we need to find our volume. Okay, that is going to be using Charles's law. V1 over T1 equals V2 over T2. Okay, that says it's 691 over 313 Kelvin. By the way, I got that from 40 plus 273 equals our new volume divided by 273 Kelvin, since we're going to STP. That will get you, that's a semicolon, that our V2 equals 602.7 milliliters. Okay, and hopefully you remember that that will equal 0.60 liters. Okay, just kind of move the decimal 3 spaces. All right, step 2. We know that 1 mole is equal to 22.4 liters. So liters times 1 mole over 22.4 gets you 0.03, sorry, not liters, 0.03 mole. Lastly, if that's how many moles there are, and that gave us this many, this many grams, we want to figure out how many grams would there be in just one normal mole. That's the definition of molar mass. So 1.7565 divided by 0.03 gets you 55 grams per mole, which is our final answer. So I know, a lot of math on the screen, but step 1, you've already done almost the entire homework. If not, well, it's due Tuesday. So do it. Step 2 is what we just learned today. Step 3 is just taking the stuff we got and finding our final answer. So there you go. That is one of the scariest looking problems you're going to see in this video. Just to let you know. Number 5. How many molecules are there in 1.67 liters of carbon dioxide at STP? All right. Thing you got to remember about molecules is that 1 mole is equal to 6.022 times 10 to the 23rd molecules. Okay? They gave you liters. We can convert liters to moles. We learned that today. We can also convert moles to molecules, apparently. That's all we really need to do this. With that, try this. Come back in a bit. All right, welcome back. So, let's figure this out. 1.67 liters times 1 mole per 22.4 liters. Now that we're in moles, 6.022 times 10 to the 23rd molecules over 1 mole. Multiply that out and you get 4.49 times 10 to the 22nd molecules. That's your final answer. All right. Lastly, what is the density of chlorine gas at STP in grams per liter? Now, you're probably freaking out saying, wait, what the heck is density? Here's the thing you got to learn in chemistry. Almost every equation I gave you derives or comes from the units that we're looking for. If you are able to grasp that concept, that if you want grams per liters, you need to find some kind of grams and you need to find some kind of liters, you can easily ace AP chemistry, basically. That's the whole concept of chem, is I want, something, I want these units. Can I find them? And you find those units, you get it to look like that, and typically that's how you find your answer. Most of the formulas I give you kind of trick you into doing that. So here's the thing. We need grams and liters. Okay, we don't have any information here using that. So that kind of makes things, except we have an STP. I'm going to let you work on this, but I want you to think about what I told you today deals with STP. Okay? That can actually help you get at least your liters. Then also keep in mind, we have chlorine. Chlorine has what we call a molar mass. That'll get you some kind of grams. Okay, so come back in a few minutes, struggle with that, get an idea, and come back. All right, so at SCP, we know that 1 mole is equal to 22.4 liters. And we also know that chlorine, that 1 mole of it is equal to 35.45 times 2, which is equal to 70.90 grams. Okay, that's molar volume of a gas. That's the molar mass of chlorine. So if that equals a mole and that equals a mole, that also means that they're kind of equal to each other, at least at STP. Which means if we wanted to report that in grams per liter, all we'd have to do is take our molar mass and divide it by 22.4 liters. And in fact, for every single gas that we're interested in finding its density at STP, we just take its molar mass and divide it by 22.4 liters. That's it. And that says that chlorine has 3.17 grams per liter. Again, molar mass over the molar volume. There you go. Well, thanks for watching. That concludes our video. And yeah.